Hello everyone. Today I am explaining one of the classic Leetcode problem, which is two sum. This problem helps us to understand the brute force solution, optimization, and time complexity step by step. Let's get started. I will read out the problem for you. Given an array of integers, nums, and an integer target, return indices of two numbers such that they add up to the target. You may assume that each input would have exactly one solution and you may not use the same element twice. You can return the answer in any order. For example, nums is having 2, 7, 11, 15 in an array and the target is 9. The output should be 0, 1 because here 2, 7 is adding up to the sum, the 9, which is the target given in the problem. And similarly, the second example is nums equal to 3, 2, 4 and target is 6. Here the index is 1, 2, which is 2, 4 is summing up to the target 6. So we have to return the indices in a pair. And also one of the constraints that they have told is there is only one valid answer exists. So I will explain how we can solve this. There are two solutions that are possible with this. One is the brute force, which is going to take order of n square time complexity and order of 1 space complexity. And the other approach is using hash map, which will take the time complexity of order of n and space complexity order of n. Let me start with the brute force approach. So for brute force, what we are going to do is, let's say the function name is toSum. This will accept a nums array and the target. For I in range of length of nums, for j in range of I plus 1 to length of nums, we will check if nums of I plus nums of j equal to the target. Then we will return the index pair, which is I comma j. So what we are doing here is we'll start with, for example, I'm taking this array. We'll start with I equal to 0th index and j equal to I plus 1, which is first index, and this is 0, this is 2, this is 3. For 2, we will check all other combinations, which is 2, 7, 2, 11, all of that. And let's say if one of the pair is matching to the target, we will return the indexes, which is 0 comma 1, right? And we in the next iteration, I becomes 7 and j becomes 11, and we will repeat the same process of checking the sum of the pairs and verifying with the target. And in the next iteration, it will become I comma j, I become 11, j become 15. If you observe here, we are checking for the first iteration, we are checking 3 combinations with 2, 7, 11, 15, which is 3. In the second iteration, we are checking 2 combinations, and in the third iteration, we are checking 1 combination, which is like, if you observe, it forms n minus 1 plus n minus 2 plus n minus 3. This is a whole time complexity, and in mathematics, this formula is equal to n into n minus 1 by 2, which is nothing but order of n square if you multiply this equation. And the space complexity is order of 1 because we are not taking any extra space. As I told, I'm going to explain. We are done with the brute force. Now I will explain the most optimized solution for this problem. And if you observe, the follow-up question is, can you come up with a algorithm that is less than the order of n square time complexity? That is what we are exactly doing now. Using hash map. To solve this problem, first I'm going to define the hash map, which is called as a scene. And for every element, okay, let me first write the solution and then explain. Okay, now I will explain the solution. So basically, we are taking a hash map, which is called a scene, and then we are iterating on the numbers one by one. And we are using one of the special keyword in Python, which is enumerate. This is going to return a tuple with the index and also the actual number in the nums array. So here for the first value, it will return 0, and it's num, which is in this example it is 2 comma 7. Sorry, it's a 2. So for the first time, it will return 0 comma 2. And now what we're doing is we're taking the complement, which is target minus num. Target is 9, and 9 minus num is equal to 7. And now we are checking if complement is in scene or not, in the scene array or not. If yes, then we will return the complement the complements index and the current index. Otherwise, we'll add this particular num to the scene hash map by doing like this, scene of num equal to I. Let me go through each iteration. So for the first time, so basically I will show you how scene array, scene hash map will look like. So the input array is to 7, 11, 15. For the scene array should look like num and its position, which is 0, 7 and its position 1, 11 and its position 2, 15 and its position 3. This should be the hash map if we do not encounter with this statement. So for the first time, in this logic, it's going to do 2, 0, and again when we get through 7, which is 1, 7, we will get the complement as a 2, and next we check if complement is in scene, that is yes, and we will return scene of complement, which is scene of 2 is going to be 0, and I, which is 1, which is our return value. This exactly matches the output. For this, the time complexity will be order of n, because we are iterating on the entire array only once. And here, when we check the complement in hash map, it will be order of 1, because checking a key inside hash map is always order of 1. So order of n into 1 is going to be order of n always. So space complexity, it will be order of n, because we are creating extra hash map to maintain the scene values so far. Okay, yeah, I think those are the two solutions that are possible for this. Thanks for listening. Please like, share and subscribe.